Welcome back, everybody. We're at lesson 1.5 today. We're going to talk about the distributive property of multiplication over addition. I know that's a fancy, long way of saying something, but trust me, you'll think you'll understand. I'll try to put it in some easy terms here in just a second. So let's just take a look at a simple problem. All right, 4 times 5 and plus 3 times 7. All right, we know that if we drop these parentheses, it's going to be the same thing as 4 times 5 plus 3 times 7. Nothing's going to change because we know we're supposed to multiply before we add. And so dropping those parentheses is not going to make a difference. But if I gave you a problem over here that looked like this, 2 times 3 plus 5. If you simply dropped the parentheses and did not do what's inside first, it's going to mess you up. Let me show you what I mean by that. Okay, let's do it the right way. We know that this is the same as 2 times, let's do what's in the parentheses first, 8, right? Which is 16, correct? Well, what if I just dropped the parentheses? We're going to do it the wrong way. This is the correct way. Let me show you. If I said, oh, well, that's 2 times 3, and then I'm going to add 5 to it. Well, 2 times 3 is 6, and plus 5 more is 11. You cannot do that. So I'm going to show you how to work out problems that are written like this, okay, especially when we have variables in there. So algebraic expressions that have variables in them. So I'm going to pull up my favorite example color. All right, so let's do a couple of examples of what you should do. Okay, so actually I'm going to go back. Let's go back. I'm backtracking here in just a second. Sorry about that. I'm going to move back over here for a second. If I did what's called distributing, and I want you to think of it this way. If I distribute papers to you all, I'm passing them out to everybody. I want to make sure everybody gets one, right? So this 2 has to be multiplied by the 3 and the 5. So if I distribute that 2 across the line, the problem would work out as 2 times 3, right, plus 2 times 5. And if we work that out, we know that 2 times 3 is 6, plus 2 times 5, which is 10, and that equals 16. And look, we confirmed it. They're the same. So we're going to practice the distributive property when we're multiplying over an addition, just like the 2 times the 3 plus 5. The 3 plus 5 was the addition, and the 2 was the multiplying. So let's do a few examples, but this time we're going to do them with variables, with algebraic expressions, okay? So if I gave you an example that looks like this, 3 times x plus 2. We have just learned that we can distribute that 3 across. We want to pass it out to everybody, okay? So that's going to equal 3x, 3 times x, and now I'm going to add to that 3 times 2, right? So 3 times 2. And if I work that out, I know that it's 3x plus 3 times 2 is 6. Now, I'm not solving this. I don't know what x is equal to, but we have written an equivalent expression by using the distributive property. This right here is equal to that. Distributing out that 3. All right, let's do another one. Let's try this one as an example. Let's say you're given 4 times 2s, there's your variable, plus 5. All right, we want to distribute our 4. We want to pass it out to everybody in there. So we're going to say 4 times 2s plus 4 times 5. We can work some of this out now. 4 times 2, I know, is 8. So that's 8 times s, 8s, plus 4 times 5 is 20. So this is equivalent to 8s plus 20. All right, now, sometimes you may be asked to do the opposite. You may be asked to take an expression and factor it. All right, so let's use a different color here. That's when the distributive property is reversed. You're pulling out what you just distributed, okay? Or you may not have just distributed it, but you're pulling out what you could later on redistribute back in, if that makes any sense. So let's take a look at just an example. I'm just going to use some letters here. A times B, and I'm going to add A times C to that. Do you see how they both have this in common? These are common factors. So if I factor this expression, I'm going to write that A is a common, to help you out, factor. Well, if I pull that out, I can rewrite it. I'm going to pull my A out and act like I didn't pass it out yet. I'm going to say that all of this is going to come down to here. A times B, taking it away from the B, plus, and I pull my A away from the C. There it is written. It's an equivalent expression right here still, but I factored out the A. I factored out what they had in common. Okay, those factors. All right, so let's do some examples going this opposite way. Or let's say that you're given, here's an example, 3x plus 3y. What do both of these have in common? They both have 3's in common. So I can pull that 3 out, I can factor it out, and I can multiply it by x plus y. So that's factoring. All right, let's do one that looks a little bit longer. Let's take 7y plus 14 plus, whoa, I am so sorry about that. I did not realize I did that. All right, 7y plus 14 plus 21. Now, let's do z, 21z. Let's add some things in here. Take a look at that. Don't these numbers look familiar? These are multiples of 7. Each of these has a 7 in common. I could factor out 7. So if I factor out a 7, I'm only left with y here, plus, now I'm going to take one of the 7's out. So 14 divided by 7 is 2, right? Plus, let's take the 7's out here. What's 21 divided by 7? 3. Now the z has to stay because that's not in common. So I factored out a 7 from these and got an equivalent equation right there. Let's try another one here just to take a look at it. We have 5x plus 10y plus 5. If you notice, 5s are in common because 10 is a multiple of 5. All right, so let's take the 5 out. What are we left with? We're left with x plus 10 divided by 5 is 2. 2y. Y has to stay. Plus, taking that 5 out, I'm left with 1 due to the identitive property. So there is our equivalent expression, and we got that by factoring it out. So that is factoring. Now the only other thing we need to talk about is like terms. Okay? So I'll do green. I don't think I've done green in a while. So we're going to talk about terms. Let's say we have 6s. We have, whoops, I meant to put plus right there. Alright, we have 6s plus 6t plus 6w. All of these are terms. Okay? Alright? So, if they're like terms, this is what we're going to focus on. That means they're similar. They have something in common. I'm going to focus on like terms. So let's take a look at 5x and 4x. They're like because their variables are the same. Okay, so this x and that's an x. So they're like, they have like terms. Alright? Same thing like right here. If I have 3y squared and I also have 9y squared, my variables are the same. They're both y squared. They have like terms as well. If I have 4y and 5y squared, this one is a y and that one's a y squared. Those are not like terms. Those are not like terms because they're different. Okay? So let's take a look at some examples of distributing if we can find like terms. Okay? So let's start simple. Here's an example. 3x plus 4x. Those terms are the same. The x's are the same. I can factor that out. X. So that's going to be x times 3 plus 4. Woohoo! Oh, and I can even do that. 3 plus 4. I can do it even more. That'd be x times 7. Or I could simply write, I could switcheroo right here. I could do the commutative property, 7x. And I'm just going to tell you that's how we like to see it in algebra, written like that. All right, if we have another example right here, and I have x plus x. Well, how in the world do I do that using the distributive property? Well, I can show you first that this is the same as 1 times x, right? We learned that a few days ago, plus 1 times x, correct? So I can factor out these x's because they're the same. So that's going to be equal to x times 1 plus 1, which is going to be the same as x times 2, or if I just turn that around, using my commutative property, 2x. There we go. Alright, let's make it just a tad harder on our last example before we're done for the day. One more example here. Let's do 5x squared plus x squared. Alright, what do these have in common? Well, they have x squares in common. And to help you see what's going to be left when I take out the x squared, because that's what we're about to factor out, I can rewrite this and say 5x squared plus 1 times x squared, right? Because that's the identity property. So I'm going to factor out my x squared, and I'm left with 5 plus 1. And we know now that we can say that's x squared times 6. And I can use the property to turn that around and say 6x squared. Alright, we're going to work on some of these too. Not tomorrow, I think it's going to be Monday. Thank you very much.